All right, so we're going to continue working with terrain now, and we're going to take the ForceGraph code that we had generated before and import it into this project. Well, this has already been done. I'm going to show you how this was done. And I changed it so that the ForceGraph, instead of operating in the game during gameplay, I changed it so we're now going to operate off of the editor in editor mode, which means that we need live or real-time updates inside of the editor environment without the game playing. So I'm going to show you how to do that trick as well. Now, the settings have also been extracted, so I'm going to switch over to, let's see, I'm going to go to default settings, and the scaling should be around 250, I believe. And let's try this. There. So you can see that we have the ForceGraph running inside of the editor. It's not playing right now. And similar to particle systems, how they can have updates that operate live in the editor without the game running, I'm taking advantage of the same feature of Unity that permits that. Okay, so we're testing it out. We're making sure the results are good. This one looks good. Of course, I already tuned this one, and I was pretty happy with it before. I also have another one in here. So ForceGraph Chaotic. I'm going to click the settings on here so we can see that. I'm going to switch to Chaotic, and it's a smaller scale. And let's try it again. There we go. It can extend beyond the island, but I set up the scaling so it shouldn't extend past the water. That was a limitation I put in there. Now, ideally, you might have other limiters on there as well that prevent it from getting farther than the terrain edge, for instance. But whatever setup you put in there, it's your call. All right, so I can also do this. So once I say I could switch it to instant, and it takes 1 frame to process it. And also, since it's using gizmos, we can see gizmos even when they're on the other side of physical objects in the game. But they do show up a little bit differently. So depending on the lighting and shadows on a terrain, like there is a dot right there, but that's hard to see. Also the scaling. On the scaling for this, am I using, I'm using chaotic. Let's go back to default, switch to default, and let's try it again. Okay, instant change over to here. Now, one thing I want to point out is on the scaling that when we expand it, it's live, it's immediate. And if you're not aware of this, that OnValidate will actually be called for objects even when those objects are not in view, because an object that shares fields with it is. For instance, if you reference a scriptable object, such as what this ForceGraph is, or what the ForceGraph settings are on, since they're referenced, the component up here is referencing this, and I change these values, OnValidate will make that the OnValidate call inside of the ForceGraph visualizer. Again, even if it's not selected. So I can still make these modifications and they happen in real time. All right, now I don't want the camera selected. Okay, so we should start diving into the code. Oh, one more thing I should show you. Over here, this is, instead of having an offset that is an XYZ where we just set it, I don't know why I didn't think to do this in the first place. I should have done this this way, but the offset was effectively just the actual transform position. I should have just used it that way. So now you can actually just drag this item around and move it up and down, and it will go to wherever you're setting it up to be. All right, now let's start diving in. So first thing I want to show is going to be the ForceGraph settings. How do we create this? Where is it? What's the code for it? Let's check it out. So here it is. It is just a class that inherits from Scriptable object. And because it's a Scriptable object, that also means we can add the Create Asset menu, which has terrain, ForceGraph settings. If you haven't used this before, really valuable stuff. That means I can right-click here and say Create, Terrain, ForceGraph Settings. Create, Terrain, ForceGraph Settings. And that produces a copy of this object. So right-click, I could put one in here in Materials if I wanted, Terrain, ForceGraph Settings, and it produces a new one that has a new set of settings that I can use. All right, but I don't want that. Let's go back to our code. So this just carries the fields, and because it is a scriptable object, it gets serialized automatically. And these are the fields that we're calling out: scaling, move force, and iterations. The frame time is no longer part of this. That is something that I removed. If you were wondering about it, I've simplified this down a little bit more, which is kind of the objective of these videos. We keep simplifying it down a little bit more, making it lighter and easier for the next round. Okay, next we have our force graph. Almost nothing changed here. Most all of the code is the same. There happened to have been one extra field in here where it was the frame time, which might have been like 1/60th of a second or 1/30th of a second, so that our math stayed roughly the same as when we were running it from one frame to execute all of it, or one frame per step. And then with that out of there, that also means that we have that time frame out of this. That means that our move force needs to be lower, because we were going down to like 1/30th of our move force before. So now, instead of being a move force of 1 to 3, we're being more of a move force of 0.01. And that's a more reasonable number, or 0.005. All right. So that's the only changes here, almost nothing. ForceGraph Visualizer has a little bit more impact. So if I scroll up to the top, we have execute always. That's great. Now, update inside of execute always only gets fired when something changes in the scene, which means you cannot use it or depend on it to have a continuous stream of updates. So we needed to make sure, like the particle system, that this could continuously operate. So how do we do it? So as long as we had execute always on, that also means that onEnable will get called in the editor. So onEnable gets called in the editor. I'm basically just calling Unity editor.editorApplication.update, and that is an event. That's a delegate to tie up a function, editor update, so that it will get regular updates inside of the editor. All right, so that's got regular updates inside of the editor. Now, one more thing on that is that when I have this object selected and I press play to get it to start, and then I click something else, it's still running. It still ran, even though I had a different object selected. So I just want to call out that processing does continue to operate. That ForceGraph update is still being called right now as I'm speaking, even though the execution has stopped. So on this, let's see, is playing. We have the editor update. I'm checking to see whether or not we if we instantiate our nodes or not, just like we did before. But there's no real changes here. Everything else is pretty much the same. Okay, it's the same as update. We're just now calling editor update. All right, so that's onEnable, that's editor update. That's how we're triggering our updates. There was a change to instantiate random nodes. How do we instantiate them? Because originally we were using X and Y. I'm going to expand this out. When we were getting the position, the starting position of where each object was, we were using random.InsideUnitCircle, where it takes a circle of 1 meter and it just puts it in there, and that returns a vector 2, which only uses X and Y. That means it matches the planes going across the screen, X and Y. Now, that worked great initially, so we could very easily see it. Our camera by default is set up to look this way. But that didn't work for the Cartesian map. We needed it across the X and Y plane, the X and Z plane, that Cartesian flat surface here. Okay, now the fact that I'm using X or Y here, it doesn't really matter for which one because it's a random start. The key thing is that I need the Y field to be 0 so that they are always at the exact same position. The big thing on this one is that the field that is 0 across all of them will not change. It will always be 0. The math will not affect that. Okay. Oh yeah, if you wanted to make this single dimensional, just set 2 of the values to 0. And it's a one-dimensional, what do you call it? Force graph, a one-dimensional force graph. All right. So then we just add that. We convert it over to a vector 3, which you can just convert a vector 2 to a vector 3 by saying, I have a vector 3. It equals the vector 2, and there. The z will automatically be 0, and the x and y are carried over. That's all the changes for this. All the changes for the random instantiator. The next part is the Andra Gizmos, which has one other minor change. And that is that instead of using an offset field like we did before, now our offset is actually the transform position. So when we move this object around, then all of the, oops, wrong one. Let's go grab the force graph. When I move that around, then all of those points move. Cool. And is that where I wanted it? There we go. All right, so also, in addition to the offset change, I'm applying the scaling to the size of the spheres that we're drawing as well. I kind of wish the line had the ability to set a width or a thickness of it, but it doesn't, and I'm not sure why. I wish it did. Or maybe it does, and I just missed it. In fact, why don't I hit comma and see if I'm lying? Nope, these are the only options for draw line. Now there probably is some tool for doing that, and I've done the math on this before to create like multiple lines so I get thicknesses and it offsets them by just the right amounts. But I didn't see much of a value to doing that here. We can see the lines well enough. They're just there for as kind of a design guide tool, a little thing to help us edit. All right, but these are all the key changes. And now I have a force graph inside of here that I can test out, make sure it works over where I want to, and maybe that scaling is just a little bit too big, so I'm going to bring it back down. Let's bring it to 0. 0 is a little too low. I want it above the water. There. And run it again. There we go. And switch to instant. Awesome. That is effectively how my terrain will be built. Next, on the next episode, I want to actually change this and apply those positions, make changes to the terrain based on those positions. Okay. Talk to you later.